All right, welcome to our first coding lesson in R. Now, before we start, I want to convince you that this is actually worth your while. So, imagine you're doing a statistical project, but you're just going to use Excel. Well, this will involve a lot of different steps where you're working with your data, creating graphs, taking averages, doing some regressions. But then it's going to be really hard to go back in time and change anything. So if you discover halfway through all of your work that you're missing some data, or actually some of the data you have you don't want to be using it, and you wish those rows in your Excel file weren't there, you might have to basically go back in time and redo all of the stuff without that data in there. Or if you wanted to measure some variable differently, same thing. Whereas with code, you will have a record of everything you've ever done or everything you want to do with your data, where it's kind of a little time machine. You can go back and change individual things and then just rerun everything without ever really having to repeat all the work again. And it will just automatically update with the changes you've made. You can just make changes in the middle of your project, in the middle of the work you've already done, rerun everything, get everything back. Super simple. So it just allows a lot more flexibility in terms of the way you actually work with data, and will ultimately save you time. That's a big one. Okay. So we're going to learn how to use R and RStudio. You downloaded it, you've installed it, so we're here, right? Now the first thing we're going to want to do is create a project. So up here in the top right corner, currently I have no project open, but if I click this little drop down arrow, then I will want to click on new project. It might ask you to say if you want to save your workspace. No. Okay. Now I'm going to click on new directory. So because I'm starting a project in a brand new directory, I'm going to click R project. Then I'm going to click browse and tell it where I want to keep it. I imagine you have a folder called econometrics or something. Please do. Don't just randomly scatter all of your files on your desktop. Just make a folder called econometrics or something like that. I'm going to put my tutorial here in a folder called tutorials. And once you're good there, you click open. And then just name it something. I don't know. This is module 2, but maybe something more memorable. So I'm going to put universities, because that's my data. Your data is house prices. Maybe you call it house prices. Maybe you call it housing. Maybe you call it module 2. Whatever works for you. Because what it's going to do after I click create project is actually create a folder. So like if I go to my tutorials folder now I've got a folder called universities, and this is where my project is going to be stored. Everything that I do here, the code that I write, the graphs that I create, anything I save will all end up in this folder. So if we click and open this folder, you will see a project where it has a .rproj project file. And what will be nice here is eventually we're going to close out of this. We're going to be done with our work here in this project. We're going to close out of it in RStudio. And we can always come back and double click on this R project, and it will open everything we've ever done in our project in RStudio again. Boom, just there it is again. Okay. All right, next. We're going to want to use data, right? So within this folder you just created, or that R created for you, is where you're going to want to keep everything that you want to use. So I could imagine you would want to go and download the data from our Canvas page for Module 2. For your homework, it will be houseprices.csv. I'm going to use the colleges one for our tutorial here. Yours should be house prices. And then you just want to drag and drop it into your folder. Okay. So the other upside of then using projects within R is that when you tell R that you want to open this data file, it's just going to search within this folder that you created. Mine's called universities. You don't have to tell it where to look on your laptop or your computer. All right, that takes us to our next step. Let me click this little green button with this white piece of paper, new file. This will open an R script. This is where we will actually write our code and save it and refer back to it, as long as we want. Okay. Now in RStudio, what you're going to see here is 4 different panels. In the top left is your scripts. You can resize it as much as you want, to your liking. Go nuts. The top left is scripts. This is where you will write your code. The top right, I usually have it on environment, but you can click around here. And environment is going to show us all of the objects we create. In the bottom right, I'm usually on plots. Plots is where it's going to pop up the graphs we create after we code it to do that. But here's a list of files, so you can see the files in your folder. Packages, we're going to talk about those in a second. And then the bottom left is the console. This is what shows you what R is actually doing when you run your code, right? So for example, if up here I do 2 + 2 and click run, then the bottom left is going to show me what R actually does with things I tell it to do. All right. Next, I'm going to click save already for this script file. So remember, .rproj is your R project. .r is a script file, like it's just code. It's just text, right? And I'm just going to call it code. If I had a more sophisticated project, like for an entire research project, I might have like a separate script file for data cleaning, creating graphs, and running regressions or something like that, and I might name them separately. But for our purposes here, I'm just going to have one script file. We can just name it that. So I'll call it code, general. And then when we look at this folder, code.r, which is just a script file, will be saved within that folder. Okay. Okay, next. We want to bring our data into R. So everything we code, we want to code in our script file in the top left panel. We could technically code everything right into the console, like you can put 2 + 2 down here and still get 4. However, nothing gets saved in the console, so everything is temporary there, and we want to save everything we're coding. So what I'm going to do is use, from the beginning here, just a basic function that R has, which is called read CSV. As soon as you begin typing in anything in the script here, it's going to try and guess what you're doing. So here I have read CSV, and it says, yeah, there's a function called read CSV. And then here in yellow, it's even going to tell me what I need to give R in order to make this happen. Okay. And I'm doing read CSV because the file that my data, the format of the data file is a CSV file, right? It ends in .csv, so I want to read this in so that I can start messing with my variables and my data of my project. So here, what I need to do is actually tell R what file to load in. Okay, now I'm going to make a mistake on purpose to show you how this works. So mine is called colleges.csv. I'm going to be very tempted to just type this in. Now if I do this, it's going to say, this is not found. But that seems wrong. Look, there's colleges.csv right in the folder. I mean, come on. All right, so let's say go to AI, because AI is very well trained to handle coding issues. So if we go here and we say, look, I have an issue with my barcode, I'm going to paste it here. What's wrong? That says it needs to be in quotes. Okay. Or maybe the issue is it's not in my working directory. But no, it's in the folder, right? So that's not the issue. Apparently I need to put quotes. And it tells me to put quotation marks. But R does not care about the difference between quotation marks or apostrophes. So like I can put a quote here and a quote here. That'll work. But so would just individual apostrophes. Also, R is very aware that people are often going to have this issue, so you can just select the whole thing and do a apostrophe. and it won't overwrite it. It'll just put the apostrophes on the outside of the CSV of the file name. And then it should work. And indeed, now we're actually getting somewhere. Good. Now you'll notice it loaded all of my data and plopped it all right in the console here. But it's very unclear what I'm supposed to do with this now, right? How is this even better than Excel? It's worse. It's just a big list of values in the console that don't make any sense. What am I supposed to do? All right, next step. In R, we're always going to be saving the things we want to keep using as objects. So for example, I might say put colleges. This could be anything. I'm just actually just naming a data frame. Here it's called the data frame, because what I'm going to do is with this little arrow to the left and the hyphen here, it's telling R, look, do this, read in the CSV file, but save it as an object called colleges. Let's see what happens when I do it. Now note, run is what makes your code run. And you can highlight the whole row and press run, or leave your cursor at the end of the row, or really put it anywhere. It doesn't matter. As long as the cursor is on line 3, it will run line 3. Let's press run. And what you'll notice is colleges now appears in my list of objects. It says you have 2,225 observations of 14 variables. Haha. So there we go. We have now loaded in our data, and it doesn't appear in the console anymore. It says, look, you ran this code, it's all in blue, so it worked, and now you've saved an object called colleges. All right. Anytime we bring in data, as a little sanity check, we can just go over here and click on it, and this will allow us to look at it the same way we would in Excel. So here's where I could scroll around and actually look at my data. Okay. It will also allow you to much more easily sort things. So like I can come in here and sort by tuition and fees just by clicking on tuition and fees, and it will tell you that you can attend the United States Merchant Marine Academy for $945, or you could go to Kenyon College in Ohio for $69,330. Okay. But here we are just looking at the data. All right, next. Read.csv is a function. All functions in R work like this. You name the function that you want to use, and then in parentheses, right after you name the function, you give it arguments. This is you telling R what to actually do with this function. Okay. Now, read CSV is just a function that is automatically in R. It already has it. However, R is completely open source, which means anybody, you, I, can create our own functions so that they can be used. If they're helpful, then they will take off and people will use them. It's great. However, any of these functions that other users have created, we need to install them and bring them in so that we can use them ourselves, okay? Rather than just using the basic R functions. So let's do that. The first package, they're called packages, what people create. A package includes an entire host of functions, right? We want to install a package called Tidyverse. So install.packages is a function that R automatically has. And now in here I want to say, look, install the package called Tidyverse. Let's see what happens when I run it. Okay. It says, great, we just downloaded it for you. Cool. And in fact, if I click on packages down here in the bottom right, it will show me all of the packages that I've ever installed. Many of these I've forgotten what they even do, but indeed, here they are. And Tidyverse is one that we will want. All right, next. Whenever you want to use the functions within a package while you're coding, you need to actually now load them in. So next step is to do library. Library loads and attaches packages that you've added on, right? So within library, you just need to tell R which packages you want to load in. And here it's listing for me all of the packages I've downloaded and I want to put in, and the one I want is Tidyverse. Boom. All right. Now, let's run it. Now in the console it says, great, now you get access to all of these functions. Very nice. You might wonder, why do I have quotes around Tidyverse in the install packages, but not here? Quotes means you're telling R that you're trying to find something that's not already here. It's like an outside thing, right? So back before we installed Tidyverse, it would have no idea what this thing is within its access to its own features or its own objects, right? It's an outside thing. After we've installed it, now all of the functions within Tidyverse are already in a place where R can access it, so we don't need to refer to it with quotes anymore. We're just telling R, look within your own files and load in all of the Tidyverse stuff. Okay, now, once we've installed a package, we will never need to do this again. We will always have Tidyverse installed in R. So this line 2, boom, we can get rid of it. Okay, we can get rid of it. But every time we reopen our project in R, we will need to load in the packages that we're using. So like library Tidyverse, I'm going to keep right here. That way, anytime I reopen this project, I will know that I should run line 3 or any other libraries. I should run those lines before I run any of the rest of my code, because it depends on access to those functions. Okay. Now, Tidyverse includes some functions that are very helpful for us in terms of data work. So it includes what is called a pipe. Okay, so maybe let's look at my data here with my colleges, right? Here I've got all kinds of different variables. And maybe I want admission, right? So this says 66%, right? It says Alabama A&M accepts 66% of their applicants. Maybe I want that to be 0.66, right? Well, here's what I would do. Let me show you a roundabout way to do this, and then I'll show you a more efficient way. First, I could do, look, take my college's data, and then I'm going to put in what we call a pipe. So it looks like this. Like this. This tells R, look, take the college's data over here, this object called colleges, and let's do something with it. The pipe says, okay, now I want to do the following. So I'm going to press enter. Always press enter after a pipe just to keep your code clean. Now, R is giving me a red X on the left here. It says it's an unexpected end. For sure, because I haven't told R what I want to do yet after the pipe. Here's what I want to do. I want to create a new variable within my college's data, and mutate is a function within Tidyverse that will allow me to do this. So when I hover my cursor over this mutate, it says mutate creates new columns that are functions of existing columns. So it's like a way to create new variables in your data. So let's do it. It's a function, so you get the function name and then you get 2 parentheses. Now, let's suppose what I wanted to do was to make this say 0.66. Okay. Well, then all I would have to do is come in here and say, look, I want to, so mutate works like this. I want a variable to be called admission, and I want it to be equal to the admission variable that we already have, but divided by 100. And this should do it. What it's going to do, what you're telling R to do, is create a new column in the data called admission, and the values it takes should be, take the existing admission variable and divide it by 100. All right, let's press run. Now, once we have this pipe in here, we can press run on line 7 or line 8. It doesn't matter. The pipe connects them, so we can press run. And now we have another mess in the console. Although it seems like it worked because here we've got 0.66 under admission, so it worked. What did we forget to do? Oh yeah, we need to actually, any work we do, we need to save it back on an object to actually keep the results. So I might be tempted to do something like this. Now note, it's going to overwrite, right? So here was the original data, colleges, and if I run line 7 now, what it's going to do is it's going to say save an object called colleges. Where does it come from? We'll take the existing colleges and do this to it, and then save that into an object called colleges, and it's just going to overwrite the existing one. Okay. Now maybe that's fine. Let's run it. All right, and then for sanity, let's look. All right, we got what we wanted. Admission is now 0.66, so this is more like in a decimal form with these percentages, so that's good. But as a word of warning, suppose we were to accidentally come back in here and click it again. Then R will just run the same code again. It'll say, okay, we'll take colleges and we'll just repeat this and save it back to colleges again. And now admission has been divided by 100 again, and it's no longer what we want. Okay? Like the more we keep doing this, it's just going to get worse and worse. So in general, starting any line of code like this is trouble. It's saying take what we already have and overwrite it with this with this command added on. But there's an easy way to do this. Backspace, backspace, boom, boom, boom. We can just put this pipe after the read.csv. And then when we run this, now we've got our 0.66. If we run it again, no issue, because it's just reading in the CSV, doing this, saving that as colleges. We will always just keep getting 0.66 because we're not taking data, doing something to it, and saving it back on itself. That's a no-no. Okay. Now you might, just as a word of advice, you might notice in online sources, either what you're using AI to help you code or you're troubleshooting something. This is a pipe, but so is this. So %, and then this greater than sign, and another %. This is also a pipe. They're equivalent, right? If I go back in here and do this, this will also work. No difference. These are both pipes that you can use for coding. So if Claude or ChatGPT gives you the % pipes, you can either code it that way or you can change them to be these ones. Either way is just fine. Okay. Next. You're often going to do a lot of things in your code that you think you will remember for all time, but you won't. In 2 weeks, you will probably have already, unless you come back and study your code every day, you will have forgotten that mutate is the thing you need to create new variables. So what you often should do is leave yourself little comments, and you can do that by using the there it is, the £. Pound tells R, look, I'm just making myself some comments here. Mutate creates new columns or variables. And then when I run this, it's a nothing. It doesn't do anything. Even if I put like the word mutate here, well, it already said mutate, right? It knows this is not a function. You're just telling yourself what's going on here, right? Mutate creates new columns and variables. This is a pipe, but so is this. So they both have that same function. All right, next. Sometimes you might get issues with your code because of the data or the variable types. And you can check this by using a function that's built in called str, which displays the structure of an object. So in this case, we might want the structure of colleges. And what it will do is it will tell you what kind of variables have you got here for all of your variables. Now note, these are very different, or the way that R categorizes variables is different than the way we might do it in econometrics, where we did, continuous, count, categorical, and qualitative. These are a little different, but R will say, look, this ID variable, these are all integers, there's no decimals. It will say name is a character variable because there's text in there. These yeses and nos for grad degrees and NCAA members, characters. It'll say admission is numeric because it does include decimal points. And R will be perfectly content to do things like add, subtract, multiply, and divide with numeric and integer variables, but if you ever ask it to do anything like that for character variables, it will say that makes no sense. And as a warning, sometimes we load in data into R, and you think you have a variable that's all numbers, but R thinks it's a character variable for some reason, and then it will give you error messages. So str will allow you to check the variable types in R and allow you to make sure that R knows this is actually a number, it's not a character. Okay. Next, suppose there's a variable we're interested in. So like maybe within this college data, I'm really interested in tuition and fees as a object, right? So what I want to do here is, let's just make myself a comment. Summary stats of a variable. Okay. These always start the same. Colleges, which means, look, I'm going to start by specifying what object I want to use. Pipe. Enter. Now, summarize is the function that's going to take you where you want to go, and summarize is going to allow you to create the measures that you want to see. So I could do mean, but I'm just naming a thing here, so I'm not actually referring to the function yet. But I'm going to say mean equals to the mean of, and now I just need to tell it what variable to use. It already knows I want to use colleges as my source for this, and now I just need to put in here that tuition and fees is the one I want. In fact, as I start typing it, it's going to give me suggestions for the variables that I'm clicking on. So here it's showing me tuition and fees is a variable. It's in the college's data frame, and it's an integer. We think it's an integer at least, and I think that makes sense. So I can click on it, and now I've got it. All right. Now I might press run on this, and this will give me the mean of tuition and fees. Oh, it's missing. Perfect time for ChatGPT or Claude. Let's ask. So I coded this, and it returns an NA. Why did this happen, and how can I fix it? So it says, look, some colleges are hiding their tuition and fees in my data. It's missing, but there's a fix. Summarize mean equals mean of tuition and fees. na.rm equals true. Okay, let's put it in. Now notice, Claude gave me a bunch of spaces. This is a preference that will be up to you whether you like these spaces or not. I don't, but it makes no difference to R. Spaces just have no effect on anything. What does have an effect is capitalization. If I do a capital T, no good. It says there's no such thing as tuition and fees with a capital T. Case matters. So in that case, pun intended, I guess. In that case, if you are loading in some data that does have capital letters, here's what I recommend. Add another pipe when you load in the CSV and use a function called rename underscore all, which says rename all of my variables that I just loaded in and then do to lower. Mine already happened to all be lowercase, so it's fine, but in general, it's good coding practice. Rename all of your variables to be lowercase, and you never have to press Shift as you are coding. So I can rerun this, but it won't change anything. It might for yours. All right, let's go back to the summary stats. So I'm trying to get the mean of tuition and fees, but it turns out some schools, I guess, are missing their tuition and fees in my data, so I put in na.rm equals true, run it. Aha, now I've got it. The mean tuition level for tuition and fees for all my universities is $23,000. Okay. Now you might be tempted to say, well, I also need the standard deviation, right? So let's enter a few times. The function for standard deviation is just SD, and then do this, SD. And sure enough, you can do this, and then it will give you that the standard deviation of tuition and fees is $17,000. We can also get really good at coding and do this, comma. But within this parentheses, because we still want to stay inside of this summarize function. So notice how when you put your cursor next to parentheses, it will show you who their mates are. So this one has a mate that is at the very beginning of summarize. So we're still inside of this function. That's fine. We can keep going by pressing enter after the comma. And then doing, now we can put in that we also want to know the standard deviation. And we can call this anything. Doesn't matter what you want to call it. Boom. You're just giving it a name. Of course, let's not call it that. Let's just call it SD so that we can see what we're referring to. Now we're getting standard deviations this way, and then you can just keep going. We want the median. That's just the median of tuition and fees, but it turns out we need to remove the missings. What this one is doing is it's saying, look, check and see if NAs are in the data, and if so, remove them. So remove the missings. Yes, please do. That's true. Okay. Now when we run this, we get our medians in there too. And we can do this with same with maximum and minimum. I think it's the same. So max equals maximum of tuition and fees. This will give us. This should give us that 69,300. Ooh. I think it might be just max. There it is. If I didn't know that, I would have just asked Claude, and it would have said, it's max. It's not maximum. And min. I think the last one would be just min. And now we have our summary stats for the variable that we're interested in. All right, next. Suppose this is really for a continuous variable, right? For continuous variables, we can characterize them by standard deviations, medians, all that. But frequency distributions for a categorical variable, maybe we want to see those instead. Okay. So same idea. Also, let me note one thing. When we go back to line 16 for this summary stats of a continuous variable, when we run this, everything just shows up in the console. And that's always going to be true when we're not saving anything back as an object. Now, maybe you want to. Maybe you want to say summary for the tuition and fees. So all we need to do is say summary, take everything we just coded, save it back as summary. And then when we press run, it'll show up over here in a new object, and it will have those values we ever want. Okay? And so here's where coding is a big deal. Now, suppose you discovered you could double your data size. Like maybe this is just 2024 data for colleges. Maybe I decided at some point, let's go get the 2023 data and add it in. So like I go in and tack on extra data into this college's CSV. Without code, I would have to go back there and calculate all kinds of means again, everything. Not so when you have it coded like this. All you need to do is update this CSV file, reload it, and rerun these chunks. And then when you check this one, it would have an updated median, max, standard deviation, etc. Everything would be automatically, boom, updated. Okay, that's the beauty of this. All right, let's move on to categorical. variables. So within my data here, colleges, one of my categorical variables is control. Is it a public university? Is it private? Is it for profit, etc.? Okay. Colleges, pipe, enter. Okay. And then the function that's going to work really well for this one, I'm not expecting you to remember this, so this is again why we're making little notes for ourselves, so we can always go back and check. Eventually you'll use the same codes enough that you'll start to be able to just rattle them off, but count is going to count how many rows match each criteria. So control, I want to count all of the values of the variable control, and then down there in my console it will say that there are over 1,200 universities that are private not-for-profit, 239 private for-profit, 752 that are public. Okay. Now typically we're not really as interested in the counts as we are like the percents. It's just much more interesting to say what percent of universities are public universities than just there are 752. Okay. Now pipes, we can just keep using them and say, look, just keep going. There's additional things we want to do. So this is where we might come in here and say mutate. I want to create a column to the right of n, which is percent of the total. So let's just call the thing percent, and then we need to think about how we could write in a function that would give me the values I want for the percent variable. Okay. Now it's n, and when we say n, R will know that we're talking about this column right here, this variable within this new chunk we've got here. Okay, so n, and we need to divide it by, now you're going to be very tempted to get out your calculator and do, 239 plus 1234 plus 752. Okay, we need to divide by 2,225. However, if you ever went back and added more schools to your data, this number would become different and this code would become outdated and it wouldn't work the way you want it to. Okay, so we would want to instead have everything coded, right? No Excel style calculations like that. So instead, let me show you the long way that we could think about doing this. Let's go back an entire step. Total equals sum of n, because sum says just sum up everybody's number. Now if we run this just applies the total to every row here, because that's just the sum of n is this, and so we created a new variable called total, which is just 2,225 for everybody. Now we could pipe this, and now you can probably see how we can make this work. Percent is then equal to n divided by total. Now we have what we want. There we go. Okay, so 10.7% of schools are private for-profit. But I really like efficient coding. So here's a hack. You can put functions inside of functions. So we can actually go back a step. Look, if we're saying, look, just divide by total, then, and total is sum n, we can actually just take sum of n and put it here and get rid of this entire line. So n, our percent should be n divided by the sum of n. Let's just make sure it works. Aha. Now we don't have this variable called total because we don't need it. And we have our percents for each category. And then the last step, if you wanted, it's called percent, so it should be more like 10.7 here instead of 0.107, but this is super easy. Just put 100 times this whole thing. Now we get 10.7. 10.7% of schools are private for profit. And now we have frequencies for our categorical variable. Okay, last. Maybe we want to look at the density distribution. It's really an estimate, but density of a continuous variable. So the last thing I want to show you is how to create a plot for densities. So always starts the same way. colleges. Refer to your data that you want to use. Pipe, enter. Now, the function that is going to help us create graphs is called ggplot. Okay. And so this is especially good because Excel stinks at graphs. I mean, it creates them, but they look horrible. Not so in R, and it's going to be rather simple for us to customize how it looks in almost every single way. The first thing you need to tell R to do within ggplot is to set what are called the aesthetics of the plot. So construct aesthetic mappings, and this is just what it says. It describes how variables in the data get mapped onto parts of the actual plot. So aesthetics, parentheses, and then it's telling you here, well, you need to set like an X and a Y, like what are the variables that are going to go on these axes. Okay. Well, in a density plot, all we need is X actually. The Y variable is in the graph is just showing us how frequent these values are. So it's really just X, and here we need tuition and fees. There it is. Okay, now let's run this. What we're saying is, look, using the college data, create a graph where the x-axis is tuition and fees. Run. Boom. All right. We didn't get very much because what it's doing is just following your commands. It's like, here you go. Here's a graph. The x variable is tuition and fees. True. All right. But we want to keep adding to it. So once you use ggplot after a pipe, it's no longer the case that we want to keep piping. Now it's a plus. Okay. After ggplot, now plus and then enter. What we're telling R to do is start adding things onto this graph. It's not like we're trying to do additional commands. We still want to use this graph. We just want to start adding things to it. Okay. And everything that we add, like this next line is going to basically tell R what kind of graph we want to make. So later in the semester, this is where we will tell R to do histograms or scatter plots or regression lines, or honestly, every single thing that it's suggesting to me in here, it can do all of them. Okay, a bunch of different kind of graphs, but the one we want for our purposes here is called geom density. It's like a geometric density is what it's doing. Okay, let's press run. We actually kind of got what we wanted already. Look, so we've got now our black line, which is an estimated density of the tuition and fees for all of the colleges in my data. Okay. In fact, just to prove a point here, histogram will instead give us a histogram of tuition and fees. But we want density. All right, next. Over the course of the semester, we're going to get really good at customizing these graphs and making them look super good, super professional. We're getting serious now. So I'm going to show you a little bits about how we would do this. First, to emphasize that we have a density here, let's give it some color. Color equals to, well, what you need to do here is I would Google R colors. And then this first link, this one that says Columbia University, will give you a big list of all of the colors that R easily can access if you refer to them. So pick a color that you like within here. I don't know. I will do, here we go, royal blue 3. That looks great. So I'm going to say color equals royal blue 3. Ooh, object not found. All right, these colors are not like within R. It's referring to outside things. So I'm going to select all of this and press either the apostrophe or the quotation mark thing. And there it goes. My version of R will literally just turn this the color that I'm referring to. Right, so if I didn't do blue, if I do black, it'll turn the thing black. Yours may or may not do that. It just depends on your version of R. All right, let's run it. Oh no, just turn the line that color. We actually want not color, we want fill. Fill it with a color. Boom, there we go. Now you could still play with the color if you want. Color equals red, that'll change the line to red. I'm good with black though. That's just the default. Okay. All right, next. You may want to allow the viewer of your graph to actually see where the grid goes within this density to be able to more clearly read it. Alpha will do this. Alpha sets the transparency of the thing. So if you go 0.1, this means like 10%. That's pretty low. 0.9 might be too high still. So, you know, use your best judgment. Say 0.6 is enough to allow for us to actually still see the grid underneath of the fill. So that'll work. Okay. Now, maybe I don't want to do tuition and fees. Maybe I want to do enrollment. And if I do enrollment, what I'll notice is, ooh, this is an extreme skew. And in very skewed graphs, if I showed this to somebody, it's completely meaningless. Because if we look back at our college's data, apparently there is a university with an enrollment of 251,000 because it's entirely online. So, all right, that's a heck of a lot. But it has to show that in the graph, therefore we can't really see what the real distribution looks like on enrollments. It has a right skew. And the way to fix that is to use a log scale on the x-axis. And this is where I want to ask Claude how to do this, okay? And whenever you're going to ask Claude for help on stuff like this, there's a couple things I think you should do to help it know how you're trying to do this, right? So mostly, like, R has a few different ways people can create graphs. ggplot is the best one, which is why we're learning how to create graphs through ggplot. So I gotta tell Claude that I'm using ggplot it knows I'm using it in R, but using ggplot, how can I make the x-axis be on a log scale? If I don't say using ggplot, it might give me a way that doesn't work so well with my actual method, which is ggplot. Okay. Now I don't want to. I didn't tell it I'm doing a density, so it gave me g on point, which is for scatter plots. So I'm just going to take this last bit, come in here, press plus, and voila. Scale x log 10. Let's make sure it works. Oh, beautiful. Beautiful. But with one exception. Really two. Number one, it's got these e's in here. No good. I usually start all of my code by doing options, SCIPEN equals 999. And you're asking, how am I supposed to know that? You're not. I for the longest time did not know how to do this. I would just ask Google a long time ago, or now Claude, how can I get rid of the e's in the listing of numbers? It's really called scientific notation. How do I get rid of scientific notation? And it would tell me, run this. So, boom, ran. Now let's try it again. All right, no e's. We get real numbers down here. And then the last thing that I would do is, if I was going to show this graph, I kind of want there to be commas at 1,000. Otherwise, it gets really hard to read. In fact, let me go back to the tuition and fees one. I actually want commas and dollar signs. So let me go back and ask, how can I also, in addition to the log scale x-axis, get dollar signs and commas on the x variable? Cool. It says within scale x log 10, tell it to label the things as dollars. So let's try it. I'm going to get rid of my spaces because that makes me happy, and press run. And now it's saying, cannot find the function label $. See how here it says, look, you get this function called label $, comes from a package called scales. All right. That's why it says library scales here. Well, we didn't load it, right? We didn't load library scales. So we need to do that. You probably also need to install scales. Install packages, scales. And then once you've installed it, you can load it in. I believe I already have it, so I can just run line 3. And now I'm ready to use the packages or the functions within this package. And now it works. I've got commas and I've got $signs on my X variable, way more user-friendly as they read your graph and get a sense for what's happening there. Okay. You're going to get some errors as you work with code, and let me just point out, I'm going to make myself a note, right? 2 most common errors in code, in R, that are going to show up. And it's not always very readable what R tells you down here in the console when you get errors, so this might help you. Number one, forgot to put a pipe. So if you forget to pipe after this one, and then you just put your cursor here, you run line 10, you're going to look at this, colleges, and it's going to not have rescaled the admissions like you liked, and it might not have lowercased your variable names. You're going to think, what the heck? Well, you didn't pipe it. You didn't tell it to keep going, right? You didn't tell it to keep going. So missing pipes between lines. Got to tell it to keep going. Number two is forgot to load the dang packages, right, that you're using. You're going to open a project in R. You're going to say, okay, I'm going to load in my data. I'm going to pipe it to some other stuff, and it's going to say, well, it's going to say, what is this thing? I don't know what this is, because you didn't do library tidyverse. So you need to load your packages as soon as you open R so that you have access to those functions. Otherwise, it's just going to say there's an unrecognized function. We don't know what that is, kind of like it said right here with label $. I don't have this function because we hadn't loaded it in yet. So that's a big one too. Okay. Otherwise, I think you should have everything you need to do the first assignment, and we now have a good start in R. So happy coding.